this. This was like the very first day of the chapter when we did approximations, and we're going to be finding the error of approximation here. You've got one of those on your test. So I've already had somebody ask me, I think it was Peter, that said on the one, find the linear function that fits at x equals 2. Peter, what are we supposed to find? The equation of the tangent line and the point of tangency is at 2. So you're going to have to plug 2 into what to be able to do that? Into the function, and that'll give you your point for your x1 and y1, and into the derivative, and what will that give you? Your slope of your tangent line. So go ahead and work on that. Okay, so if we plug 2 in, like Peter said, plug it into the original, what did you get for your y value there? 8 minus 6 plus 4 is what? Minus 6, don't forget. So you end up with 6. So we have the ordered pair now, 2, 6. And then for the slope, you have to know the derivative. What's the derivative of f of x? 3x squared minus 3, and then we plug our 2 back into that. So 3 times 2 squared minus 3 is what? 9. So that's my slope. That's the slope of the tangent at 2. So what's the equation of my line for my final answer? Y equals 9, x minus 2, and plus 6. Remember, I told you back, I think after chapter 3 when we did tangent lines, you would have an equation of a tangent line on every test from now till the end of the term. Well, there it is for the next test. That's how it's going to show up, okay? Now, the next question here, be careful, because if I remember right, on the test, for some odd reason, people put this into weird places. It says, using the equation you found in part A, which is the boxed in red one, approximate f of 2.01. And I think people plug it back into the original equation, but you don't do that until the next part. All you're going to do on this part is plug that 2.01 back in to that equation. So it becomes 9 times 2.01 minus 2 plus 6. And see, this is the way we had to do things back in the old days when you had to walk 5 miles in the snow uphill to school both ways, and we didn't have calculators. This is the way we had to come up with an approximation back in the good old days. Well, I say they were good. They were good old days. We didn't know any better. We didn't know any better. We didn't know about graphing calculators. All right, so we get 0.09 plus 6 here, which is 6.09. So that is our approximation the old-fashioned way, without a calculator. Abacus. Well, they had abacus, they had slide rules. I didn't have to use those. I'm not quite that old. We had some calculators, but they wouldn't do all the stuff that your alls do. I didn't use a slide rule. I have no clue how to use a slide rule. I'm not lying to you. All right, so the error in approximation. Keep in mind that we did absolute value. Now, if we were approximating 2.01, we have to plug, to get our error in approximation, we have to plug the 2.01 back into the original now, and then we'll subtract the approximation we just got, which was 6.09. So what was our original equation? X cubed. So 2.01 math cubed minus 3 times 2.01 plus 4. That's from your original. I just didn't flip back up there. And then I have to subtract the approximation I just got of 6.09. And I don't think I need any extra parentheses in there since it's all addition and subtraction. Well, come on. There we go. Yeah. Okay, so if I do this, did you guys get that same 6.01 e negative 4? So tell me what number that would be. Now where did the zeros go though? It's a negative exponent. Yep. I have to move my decimal 4 places to the left. The first place takes me behind the 6. So I have a decimal with 3 zeros and a 601. So if we rounded it to 3 places, it's just 1,000th off. So see, back in the good old days, that wasn't too bad a method of approximating. Now sometimes it'll be a little further off if the curve is real steep, but we couldn't check our, well, we would have had to use a calculator and just plugged it in like I did there. You guys could actually have plugged in the original equation and done all sorts of things to come up with the actual value. You know, y1 of 2.01 or gone to trace. Yeah, you just don't have to use your brains as much to find all these answers. Well, you do have to know how to use the calculator. All right, is everybody okay on that one? Okay, let me flip to the, any questions? You guys that are using the dry erase boards, you okay? All right, let me flip to the next one and I'll let you write that one down. Actually, those two. We did some like this, so I'm going to let you practice these on your own and then I'll come back with answers here in a minute. All right, first of all, make sure on your antiderivative here that you do negative cosine of x. And if you are not sure if you have your sign right, take the derivative of that. Because remember, your definition of antiderivative tells you that if this negative cosine of x is the antiderivative, then I ought to be able to take the derivative of it. Derivative of cosine of x is negative sine of x, and that negative out in front will cancel so that we just have sine of x. Then you plug it in. Most of you guys have already done this. You had negative cosine of pi minus, and then opposite of the cosine of negative pi. And the cosine of pi is what? Negative 1, and the negative out in front makes it 1. Minus minus, so that becomes plus. Now the cosine of negative pi, guys, you're getting actually to the same angle here, or same spot on the unit circle. That's positive, the green there. If I go negative pi and I flip around and go this way, I end up on that same ordered pair. I just went a different direction to get there. So I still have negative 1 as my cosine, so they cancel each other out. Now, for the next one, we're going to look at this kind of like what you did on Friday, or Tuesday, I mean. We looked at the actual graph of the sine and talked about that. Sine graph starts at a root, right? Well, this thing's off again. But it goes up like this, and then down like this. And if you will remember, we said that each of these little pieces was 2. And then that one's down below, so it's negative 2. Do you remember that? I don't know if you remember the 2 part, but you remember looking at that graph? So on the next piece here, remembering, and that actually is a true value, because if we did the antiderivative from 0 to pi, we would end up with 1 plus 1, which is 2. Okay, so that is an accurate number. You don't have to recheck it. But if I want to do the absolute value of this, then that takes my graph and flips this piece up here. And so I end up with a positive 2 and another positive 2. I'm not even going to look at the antiderivative because we don't have a rule yet for the antiderivative of an absolute value. Remember, the derivative took absolute value over the regular just sine of x. I don't remember if that's on there. I'll look here in a minute and see if we've got a rule for absolute value. I think we probably do, but so oh,